Tokens are how AI reads, because again, they're the alphabets of the model, and embeddings are how AI understands. Hi, and welcome back to my channel. As usual, my name is Debola Ibiode. I want to say a big thank you to all my recent subscribers and all the returning subscribers who are watching this video. So it's a massive thank you. That's a love sign. I have bent fingers. I hope I got that right. That's a massive thank you to all of you for supporting this channel, because this is a very young channel. It only started February of this year, and we're into thousands of subscribers, and so I'm very grateful for all the returning subscribers and all the new subscribers as well. So for those of you who are new in this channel today, what do we do here? So here, all we do is we demystify and democratize the knowledge of artificial intelligence to everyone. So all I'm doing is demystifying and democratizing the knowledge of AI to everyone. So if it could be developers, innovators, creators, everyone who is a budding AI enthusiast, an AI consumer, or an AI creator wanting to be an AI creator, this channel is for you. So I'm here to democratize that knowledge by explaining key terms in artificial intelligence in simple terms. Okay, so it makes it easy for us to have a good understanding of how we can use the technology to benefit us in our daily lives. Yep. So that's what we do in this channel. So if you're new here and the algorithm brought you to me, welcome. Thank you for tuning in. And if you would please be kind, you can subscribe below so you can have more videos from me as well. And this channel is not just about me, it's a community, because what also happens here is we have members of this channel who would also subscribe topics that I should talk about. So my last video was on algorithmic bias, and it got a lot of views and it got a lot of feedback, and everyone seemed to really like that topic, and it was a topic by one of the subscribers on this channel as well, which we talk about how we can reduce algorithmic bias through machine learning, or in the process of machine learning. Yep. So that was a massive topic. It wasn't, I'm not going to take benefit or credit for that topic. All I'm going to say is that topic came from a subscriber, and I was able to explain it to everyone. So thank you for those who left nice comments on that video. The videos are somewhere here or here, wherever we place them during the editing, but I did it into two episodes, I would say, or two videos of algorithmic bias, where we talk about how we can detect algorithmic bias in existing models and what we can do in the machine learning process. That's in the second video. What we can do in the machine learning process to reduce algorithmic bias, algorithmic bias fully, as much as possible, not totally, but as much as we can. So those videos are somewhere on my channel. You can also go and watch those videos. But that topic is from a subscriber on this channel. So when you subscribe to this channel, you are also part of the community, and I encourage that you participate, suggest topics that you want to learn about, and then we can take you from there. Okay, so let's dive right into today's topic. So stay tuned as we dive in. Hi, and welcome back quickly. So let's quickly dive in. So today's topic, we'll be talking about embeddings. So embeddings explained in simple terms. In today's episode, I will be telling us what embeddings are, how embeddings work, all right, and also relating to what's the difference between an embedding and a token, and also explaining where they're being used, what the misconceptions around embeddings are. So giving us a full understanding of what embedding is. Now, embeddings to me, right, and I'll explain it this way. Embeddings are the secret language of AI. So it's like AI's hidden power. Like I've said in many of my episodes, that everything we do in artificial intelligence is still very mathematic inclined because it's part of computer science or computing as well. Now, embeddings are hidden powers, or is the hidden power of AI that runs the knowledge and understanding aspect of an artificial intelligence model, an AI model, right? So by way of introduction, I would say this. Everywhere you look, right, whether you're a developer or an engineer or not, or just an AI enthusiast, you would have heard the word embeddings. And just by saying this, I would like to tell us why I picked this topic today. So I normally do trainings. I teach people coding, and now I teach people how to build AI agents or how to build their RAG model. So I take, because I'm an AI engineer, so I teach people how to code for that. Now, one of my training last Saturday, one of the developers, and most of my students are developers because, well, again, it depends on what you want to refer to yourself as, because I get corrected a lot nowadays, developer or engineer, however you relate. So if you're an engineer or developer in this community, what would you rather be called, a developer or an engineer? I call myself an engineer, but if you call me a developer, I'm also fine. Software development, software engineering, they're one and the same to me. But most of my students are developers or engineers. And so that means they are coders. They write code, they build system and all of that. And in that class, a student did ask, what is an embedding? And I was very proud of him because most of us walk around, especially us engineers, because we build this thing. Now, this person asking just finished a master class on how to build a RAG model and an AI, and then use that in its AI agent, and how to implement an agentic framework. So that's what the lesson last Saturday that I taught was about. And so that means he's able to create embeddings through code. But then he took the courage to actually ask what embeddings are. Okay. And I was proud of that because most of us don't actually ask, especially as engineers. We just build this thing without understanding what they really are. And that's what drove me to creating this episode today. Now, embeddings, we hear that a lot. So if you're within the AI space, you would have heard embeddings or you would have heard tokens. And I hear some people also misrepresent tokens as embeddings. So using tokens and embeddings as the same thing. They're different. We're going to talk about it later on in this video, so stay tuned. And I think it's about time to explain what embeddings really are. And I'll start by saying embeddings are AI's secret language. It's the hidden power behind AI that helps it to understand meanings to words. Like I tell people, AI doesn't really know English in that sense, doesn't know our language in that sense, but it's able to use mathematical representations within itself to attach meanings to the words that we ask it or send to it. So AI embeddings rather power RAG. And what is RAG? In one of my early videos, I talked about Retrieval-Augmented Generation. Now, RAG is a way of ensuring that we can ground our LLM's knowledge to a specific domain, right? RAG is a way of empowering LLM to be able to be an expert in a set domain. And what is RAG? Retrieves this domain-specific understanding and passes it to the LLM to augment the LLM's understanding, and then the LLM is able to generate a domain-specific expert answer to you. So that is retrieval, augmenting LLM, and LLM generating an answer. And that is what RAG is. I have an episode on what RAG is. And just a quick question to know who my true community followers are. Is RAG an AI model? Put your answer below because I did talk about that in a video. So that's what RAG is. RAG helps to ground the knowledge or the truth of an LLM to a specific domain so the LLM can be an expert in that domain. Now, embeddings power RAG. They also make search smarter. So when you're searching for something and it's able to search, if you're using a system that is searching like recommendation systems are built on embeddings. So embeddings sit quietly behind the scenes of recommendation systems, where when you make a search about something, it can give you the answer specifically as well. But what exactly are embeddings and why are they so important? Now, this is how I would explain it as simply as possible. See embeddings, and embeddings are vectors, right? So, or an array of numbers, however you want to say it. Now, see them as GPS coordinates, because what other system uses like an array of numbers, or is it if it's a tuple, or I'm saying technology terms now, but when you put numbers in a bracket, either square bracket or curved bracket, right? Now, a GPS coordinates are usually in a curved bracket. Embeddings are vectors, and vectors are usually in a square bracket. So numbers separated by comma following each other. I'll show us as we go along. Now, when see embeddings rather as GPS coordinates of meaning. Okay, now an LLM doesn't really understand what a cat is, but through its embeddings, which is a GPS coordinates to what the word cat is, it's able to know the meaning of cat. So how do they do that? They tell us where words and ideas live in relation to one another. So they see the similarity between words and ideas, and the embeddings are generated based on how a word relates to another word. And that's how it can bring contextual meaning when it's responding to you. And that's why it's able to respond to you like a human being. It's not like you understand ABC. Like you can't say to LLM, like as kids, they teach us A, B, C, D, E, F, G, and then we build on that to then know how to create words and all of that. LLM doesn't know all of that. You just give it the full book, isn't it? So it needs to be able to get the embeddings, which are the GPS coordinates of those words. And the GPS coordinates are generated based on how those words relate to each other. Okay? I'm using the word GPS coordinates so I can help us understand it better. But we'll go into what they are. They really are vectors. So I would say, in simple terms, embeddings are just numbers. All right, see them as numbers, but not random numbers, right? They are numbers that help capture the meaning of a word. Now, if you say to an LLM, king minus man plus woman equals, the LLM will say queen, right? How is it able to do that? It's able to do that based on the embeddings, because the word king, man, woman, queen have similar embeddings that show how they relate to each other within the high dimensional space of words that exist in the LLM's memory. Okay, so the way I want us to see it is, think of thousands of dimensions. So basically, I'm trying to find an easier way because I want to use simple terms. So bear with me 1 second. LLMs use embeddings to capture relationship between words, right? The relationships that are captured between words help it attach a meaning to the word. Giving the example again, king minus man plus woman, the LLM knows it's queen because their embeddings show the relationship between all those words together. Okay? Now, how is he able to do that? It works because embeddings place the words in a huge space. So think of thousands of dimensions where a dimension is a variable or a feature. So for example, in a data set about people, each piece of information about a person, say the age, the weight, the height, the income, they are dimensions. So those are properties of that person. Now, he's able to draw, let's say the LLM is able to draw a family tree. He's able to draw a family tree because he knows that if there is a child here, and this child is related in that white space, is near another child, and both of them are near a certain woman as a mother, is able to, I'm just giving you literal terms so you can see it. It's able to use embeddings, attach embeddings to these people to create a relationship between them and other people within that high dimensional space. Right? I've used people because it's easier to follow, but this is it doing it on words. So it's a huge, so it places words in a huge space and uses embeddings to identify their relationship with one another. So words with similar meanings end up close to each other. In simple terms, embeddings turn language into meaning-rich numbers or vectors. I'll start using the word vectors going forward. So it turns language into meaning-rich vectors. And vectors, you see them as an array of numbers. So the AI can reason about an idea, not just the letters. Okay? So embeddings help the AI or give the AI the ability to know what a word means. And that's why LLMs can respond back to us in human-like fashion. Now let's go into how embeddings work. And I'll start by trying to clear the misunderstanding between tokens and embeddings. Now, like I said, if you're in the AI space, you'll be hearing a lot about embeddings and also tokens. A lot more about tokens if you're a non-technical person. And that's because LLMs are costed by the tokens that they carry, isn't it? When you hear about the context window, which is the amount of memory space available to an LLM to be able to process information, it is also measured in tokens, how many tokens it can carry. Okay, so LLM's brain in that sense is measured in tokens. Now, people often use tokens and embeddings interchangeably, but they mean different things. They work together, right? But they mean different things. They both help the LLM in understanding and applying meaning, but they do different things as well. Okay? Now, so see tokens. Tokens are like the alphabet of the model. You know, like I said, as a human, when we're learning, so if you're being taught English, right, you start with the alphabet, A, B, C, D, and stuff like that. You can do that with an LLM. Now, tokens are like the alphabet of the model, all right? So they are raw numbers assigned to words or even parts of the word. So for example, the word cat might have a token of 3942. It's just a random number made up. Nothing magical about it, just an ID. So every word has an identification number. Let's put it that way. Every word has an identification number. Now, so that's what a token is. Embedding, on the other hand, are numerical vectors, which is a long list of numbers or an array of numbers that capture meaning. So for example, cat, right, might map to something like into a square bracket 0.12 slash 0.45, not slash, comma, just a list of numbers. So the word cat will be mapped to a list of numbers, and that's the vector. So that list of numbers, remember, embeddings carry the meaning of the word because they are generated based on how that word relates to other words within the high dimensional space where the words exist within the model. Okay, so cat would have a vector or attached map to it in a high dimensional space, whereas a token is an identification number to the word cat. Okay, so an analogy will be tokens are like the letters on a map, just like labels, and embeddings are like the GPS coordinates showing where the city is and how close it is to other cities. All right, you should see it that way. So tokens are how AI reads, because again, they are the alphabets of the model, and embeddings are how AI understands. I think that even I'm impressed. Ignore me. So I'll say that again. Tokens are how AI reads, and embeddings are how AI understands. Remember, if you see tokens as the alphabet, the ABC of the model, embeddings are the GPS coordinates that carries the meaning of words for that model. So again, tokens are how AI reads and embeddings are how AI understands. So see it that way. Now, just to dive a little bit into tokens as well. Now, tokens, because people are still going to ask, but since they're both numbers, why, how do they both then help in the process of embedding? Now, tokens, the purpose of a token is to allow the model to process the text, right, in a manageable form. Now, so for example, I'll give you a usage of a token. So a token is like the smallest unit that an LLM can work with, basically, right? And when in every process of LLMs answering you a question, there's always a tokenizer, right? If you're a developer, you will hear the word tokenizer. Now, depending on the type of tokenizer, what's a tokenizer? When you send a message to an LLM, it has to tokenize your message. So every word has to be converted into tokens, because LLMs speak in tokens. Remember, tokens are how the AI reads. So for the AI to be able to read your question, it has to convert every word or subword or character. So it depends on the type of tokenizer being used, right? It has to convert every character or word or subwords within your question into tokens so it can read your question. Right? So the purpose of that is for the LLM to be able to break down your question into pieces that can help the model then understand. Right? Remembering the example I gave, if you had cat with a token ID of 3912 and cat with a vector embedding of a list of numbers, right? It will be 3912 represents this list of numbers. Okay, so it needs to convert your words to tokens so it can fetch the embeddings, and through that embeddings it understands the meaning of your words, and it can then find similar words through embeddings that are similar to the words that you're sent in to be able to give you the appropriate answer. So now you can see on screen an image which I got free on the internet. I googled just a diagram to explain LLM, and I got this free. So if you're the original owner of this image, I credit you. I just don't know who the original owner is. I just copied the image from the internet. You can see the tokenizer, the token IDs, and the input at the bottom. Remember I said that when you go to a chatbot, so you go to ChatGPT, for example. In ChatGPT, you type in, the teacher taught me something. Or you type, okay, let's give a better example, not the one on the image I'm looking at. What is the capital of France? Right? You've typed in that word. When that word goes into the backend system of ChatGPT, depending on the tokenizer it uses. So let's assume that the tokenizer tokenizes into words, right? It's going to have what is the capital of Paris, France. Sorry, is that what I said? I can't remember what my question was. Now it's going to break each word in your question and then pass it through the tokenizer. The tokenizer will then generate a token ID for each word. Within the LLM's trained memory, in the huge space where words rely, it's now going to fetch the embeddings of each word to know the meaning and then use that to give you a sensible answer. Okay? So, input, carbon markets are growing. I've used that because, again, I'm a founder of a product called Carbon AI. So everything I'm talking about is around carbon at the minute. So carbon markets are growing, right? The model will process the token sequentially, and then each token is then mapped to a vector via the embedding layer as well. Okay, so there's another one which is a very good image as well. I found this online as well on Google. You can Google these things and you see these images. Okay, now tokenization or LLM tokenization is you inputting a text, like I explained before. On the screen now you see hello world, and then there's a pre-processing where you then have which then leads to the tokenization algorithm that divides into words. Tokenization algorithms are different. Some people use subwords and stuff, or some tokenization algorithms even take phrases, depending. But this is simple enough. I just want some water, sorry. And it tokenizes your sentence into words. So in this case, hello world, and your token IDs are that number, right? And in the LLM's memory, there is a vector representation of that token ID, of that word, okay? And that's how it's able to read your word and understand your question, right? It reads and understands. So it uses the tokenization to read what you've sent to it, and then it uses the embeddings to understand what you're saying. Okay? So pretty much that. So let's go into embeddings as well. I think I've explained it in all my analogies, but let's see it this way as well. Embeddings, like I say, are vector representation of tokens, words, sentences, or documents in that high dimensional space. And when I say high dimensional space, is this large data set in a data center where all the words exist with all the dimensions for those words. And I give you an example. What a dimension is. It can be a variable, a feature, whatever. Right? So in this high dimensional space, embeddings are the vector representations of the tokens, right? Now, the purpose for embeddings is to give meaning. So it captures the semantic meaning. Again, so king and queen are close. So when you say king minus man plus woman, you would say queen, because within that vector space, all those words, in that high dimensional space, all those words are close to each other, so their meanings are related to each other. But if you say king and banana, they're not related. They will be far apart in that entire high dimensional space of the AI model. Okay, so embeddings, like I say, are the GPS coordinates to words. So they're useful in RAG, and they're also useful in classification systems, right? Recommendation system, in systems that are trying to look for similarity in understanding. So semantic similarity with how close is this to this other thing. It's that there is a popular algorithm that we use in engineering called the cosine similarity. We use that when we're trying to build chatbots as well, right? So it helps us in finding the cosine similarity within the model space to give the right answer as well. Okay, so that's what embeddings are. I hope that is clear for us. Okay, so how do embeddings work? I think I've explained it in explaining tokens, but I'll put it this way. So in short, like I've said, tokens are IDs to letters. So they are the alphabets of the AI model. So they are like letters or words broken down for that model, and IDs are attached to them. And then embeddings are the meaning encoded as numbers in this high dimensional semantic space for each of the words that now have a token ID. Now, when the token ID is passed through the model's embedding layer, it then becomes a vector, right? So you would have token ID. So in the case of cat is 3912, will map to an embedding of a list of numbers in that vector high dimensional space. Which is why when we're building any system, we always have to split our text into chunks. Okay, we have to split our text into chunks because the chunks, which is what the tokenizers do, represent a numeric ID that is a token for that chunk, right? Embeddings carry the meaning, and by both of them working together, the LLM can respond to you appropriately. Okay, so I think I've explained that as much. If you have any questions, you can ask below. So why do embeddings matter, right? Embeddings matter, or well, I can say, why should you care, right? Again, it depends on how much of artificial intelligence you want to understand. If you're someone curious about artificial intelligence, you should understand this, right? But why should you care? Embeddings power so much of what our current modern AI systems are. A lot of our AI advancements right now are built on the large language model. That's the greatest advancement so far, where we can have systems that can respond to us in a human form. So no matter what function we give to it, we still need LLM. So in all our AI agents that we're building within the agentic framework, LLM becomes the reasoning element of the AI because we use that to be able to pass understanding, perception to that AI and stuff like that. So embeddings power so much of the modern AI that we use now. So especially in RAG, right? For those of us that build domain-specific chatbots, we would have built a RAG model, and that RAG model are built on embeddings, and that is what is retrieved to augment the LLM's understanding and process to generate an appropriate answer as well. So in search engines, embeddings enable searches. So if you type doctor, it is because you typed in, because of the understanding through embeddings, it can also bring up results like physician as well, because they're similar in that high dimensional space. They are relatable within that. Okay. Embeddings are also useful. I started with recommendation systems as well, where embeddings help match your preferences with items that are similar in meaning to what you searched for in the past. All right. So embeddings make systems smart, basically. Without embeddings, AI would just be a pattern matching text system. Embeddings is what gives it understanding. So with embeddings, it gets context, it understands nuances. When people say AI is sentient, it's because of the power behind embeddings. So embeddings are critical in artificial intelligence today. So what are the common misconceptions around it? First, embeddings are not models. I asked a question earlier, is RAG an AI model? We do say RAG model anyway. So is RAG an AI model? I'll leave you to still answer below. Embeddings are not models. They are the output of a model. So in a RAG model is filled with embeddings, built on embeddings. So the output of a RAG, when you're trying to retrieve from a RAG model, what you're retrieving are embeddings. So they are the output of models. They are not models in themselves. So embeddings are not models. Another thing is embeddings don't store dictionary definition. So, when you look up what's the meaning of, what's the word now? Analogy. And you look in the dictionary, it will give you what analogy means. That's not what embeddings are. Embeddings are not dictionaries. They don't know that a cat is a furry animal. They don't know that a snake is something long and sliding on the floor, right? They don't even know that a cat as a furry animal also meows. They don't know that in that sense. What they store is the relationship between words. So cat is close to dog and kitten, but far from volcano, for example. So they understand that. And wherever within that I-dimensional space, if the word meow exists, the word meow would exist as a close relationship to cat. And that is how it's able to know that a cat meows. But as a machine, it actually doesn't know if a cat is a furry animal that meows in that sense. So embeddings is what helps it understand that in that sense, because it uses the vectors to find how they relate in that high dimensional space where words are. Yeah. So when you are looking at embeddings, they are not dictionary entries where, you can go to a dictionary to give a meaning to a word. That's not what they are. They are more of relationship between words. So think of embeddings. When you think of embeddings, think of relationships, not dictionary entries. Okay, so those are quick ones. So now let's bring it home to end today's topic. I like that phrase, so I'm going to use it again. Tokens are how AI reads. Embeddings are how AI understands. Embeddings are the secret language of an AI. Like I say, AI doesn't understand English or Yoruba or French or Spanish. It doesn't. But it understands embeddings. So embeddings are the secret language of AI, of artificial intelligence. And they are the hidden layer powering retrieval-augmented searches, right? They are the hidden layer powering recommendation system. They are the hidden layer that helps AI capture meaning, not just text. So next time you hear the word embeddings, remember, they are the secret coordinates of meaning inside of an artificial intelligence system, of an AI. So in our next episode, because this is rounding up on embeddings in simple terms. In our next episode, we'll look at hallucination in AI. Yes. AI is a stochastic, LLMs, not AI in itself. LLMs are stochastic in nature because they are built to generate random things, isn't it? They rely heavily on embeddings to generate with meaning, They rely heavily on RAG to generate with grounded truth, but LLM is still LLM. And so there is the issue of hallucination. LLMs are not, sorry about that, deterministic systems. 1 second. So in our next episode, we will be looking at hallucination in AI. Why even with embeddings, because I did say embeddings give it meaning and embeddings give it the power, but why even with embeddings, AI sometimes make things up and what that really tells us. So that will be our next episode. But on this, again, I'll end by asking, so do we understand what embeddings are? Do you have other examples of how you've used embeddings, or what you think, or how embeddings have been used in any project you're working on? You can leave comment below. It's a discussion. Let's talk about it. Do you know what systems best benefit from embeddings? And the token embeddings debate, are we clear on that now? Tokens are not embeddings, all right? But they work together to help the LLM be able to respond in a human-like fashion. So thank you. It's been my pleasure today, and I'll see you in the next episode. Bye.